You are.
Hello, everyone. Welcome to my presentation. I'm Florian. I work at Gina AI, and I realized on this conference quite a lot of surprisingly many people knew about Gina AI, probably because founder Dr. Han Qiao, he came from China and went to Europe and started in Berlin his company Gina AI 5 years ago. And since then, we developed a lot of open source projects. You can see we have a total 30, even more open source projects, and with 30 people, I think this was quite nice, good achievement. I'm actually quite proud of working there. And then here are our products. So we are this search AI. You can think of us like all the things you need to build to make AI be very good at search, AI applications. So we have the project called Reader. Reader is a program where you can put in a URL and then retrieve the website as LLM-friendly format in Markdown. A lot of LLMs have a bit of issues working with the HTML content directly, because you can think of it's very polluted. All of this div elements and so in HTML websites, it's not so good for a language model to understand. So instead it uses Reader, it can use Reader as a tool, and then gets the nice Markdown language format. And then we develop these embedding models. If someone has some questions regarding embedding models, you can come later to me, because quite scientific topic, a lot of things we can discuss about this, but too much for this presentation. Re-ranker is the same. So these were all the marketing slides. Now we're done with this part, and we can go to the most interesting part, which is Agentic search flow. So the mission for today is to enable all of you building your own agentic search. And just to match the skill level, because we are a small group today, it's quite nice. It means we can have it very interactive. And first I would like to get a feeling of your skill level so I can adjust this presentation. So who is doing like implementations yourself? Nice. And who was doing rec applications before? Okay, not so many, but some people. And who built even agentic search flow before? Thank God, not everyone. Otherwise, I would just leave. But I hope even for you, it will get some nice insights. And you can also challenge me with tough questions and later on, or also in between. So I give you a small overview from where we came in the field of search and where it's going. So we came from this keyword-based search engines, where you type in a keyword, and then if it's not matching perfectly, then you would not retrieve this document as a search result. Then we went to semantic search, where the documents you retrieve match your query in a semantic way. Then even combining this through hybrid search, and now we enter this time of agentic search. And I will explain all these steps now a bit more detailed. So, keyword search. It was like this that, or still a lot of search engines use this, that when, for instance, you have a query like best budget smartphones 2025, you want to get them, then it's good. With keyword-based search, you get all these documents where they contain budget and best smartphones and 2025 in the exact same way, and that's good. But there's also many documents you don't get maybe they use different wording. For instance, instead of best, they use affordable, or budget instead of affordable, or best, like perfect ones, and this year instead of 2025. And you could find your way around with a synonym list. You can list all the synonyms and then make more search queries to the search engine, and also find these documents where it uses other keywords. But especially people who worked in the field of search before know this is really a tough problem and grows exponentially of what corner case you could think of. Also, what about spelling mistakes and so on? So this is not an approach with synonym lists or so. But then people found solutions, semantic search, where you transform the query into a vector representation, and you do the same with all your documents in your database. And then you perform your search and you get things like this. You get, when you look for purchase, Samsung, and then a certain ID of this, or version of the smartphone, then you find this in a search results. And this was great, even if it's saying buy instead of purchase, because it matches the semantic relationship. But it also still suffers from issues like version number. Because for semantic model with a vector representation, it cannot capture all possible versions and numbers, and it simplifies everything to semantics, and it places all the versions IDs actually very close to each other. So for the embedding model, this is not much of a difference. It's just this random string in the garbage corner of the embedding space, basically, and putting them very close together. So that's why with semantic models, you get, for instance, this as match, even though it's a totally different version ID, and for you, it would be no-go to buy such a smartphone. And that's why people use hybrid search. You can combine the best of two worlds, ideally not the worst of two worlds, but the best, namely that you can find exact IDs in your data set when required, like certain filters. For instance, in e-commerce, you want to have a certain size of clothing, or you want to have a price range. There's no like semantic equivalent price or so, not negotiable. You have your budget you want to spend on. So you have these strong filters, but then you also have the semantic relation to capture all the different ways of typing things. But of course, the story goes on, and we still have certain things that don't work. And one of these examples that don't work, I would like to show you here. So the query would be comparison of Google Cloud and AWS pricing. And of course, with our hybrid search, we would find that single website that contains the complete overview of all the AWS products and the Google Cloud products, and we will find that. The problem is this document doesn't exist. It doesn't even exist on, even an overview of all Google Cloud products doesn't exist on one website. Right, so you cannot answer this question with a single response, a single query from the response from the database, because this document doesn't exist. But instead, this information is spread out through many different websites. And what you actually should do is, what you would do probably, you would first look up what products are there, and then for each product make an independent search, and then also get a response from them and dig deeper and compare the different variants, and then find the pricing, and finally all your investigation results you put together into one final answer. So it means the next paradigm we're now facing is agentic search. And this is exactly doing such thing. We get, instead of just one document from the database or one query, we run multiple queries. And I would like to just illustrate you how this works in the most simple case, because I think we should start very simple. And I would like to enable everyone to build this very simplistic thing and then apply this to your company, to your data, and you can implement agentic search within your company and can solve the challenges you face there. So here, this is the human, and then this is our AI agent. The human asked, cheapest GPU with 80 gigabyte VRAM. And now the agent doesn't directly answer this question because its knowledge cannot be found within the weights, or it's maybe not confident enough about the answer. And instead it uses a search tool and then provides, then the search tool provides answers, and the agent thinks again, should I make another search or should I give the final response? And it doesn't give the final response in this case, it makes another search query. Now it's searching, after finding out what are the GPU providers, it finds out about certain GPU types and where the pricing is lowest and lists all of them. Yeah, now another iteration finds specific offers of the GPUs, and only then it gives a complete report at the end with all the detailed information and the links where you can find this. So, but now I told about the interactive part, and here it is. So, the question to you: do you see or saw this conference probably, and we'll see a lot of illustrations like this, or a friendly little robot, and we think of it like this magic thing that is doing something, or some people might think it's just LLM or so. I don't think so, it's more. So I would like to hear from you, what do you think is this robot? What is behind this illustration? Anyone? Yes, please, or you can just scream in. I can come to you.
Yeah, I think you can make the agent with a system accession prompt to define what you want, and you can get what you want.
Mm-hmm. Yeah, so yeah, this is definitely an LLM, and a prompt is very important. And I think it's it's also a piece of code, maybe probably obvious for you, but just for completeness, it's a piece of code, a loop, where this code is executed. So prompt, LLM, and a code where it's running in the loop, again and again, calling the prompt. And I don't expect anyone to read this. I just want to show you how short such prompt can be that is already able to do this behavior I showed you before. You really don't have to read it, I just explain you roughly. So the first part is just, you use this cool AI agent, and then we give it the user input. We tell it, this is what user wants from you every time we give it. And then it's a list of question-answer pairs. This is what you asked before, and these are the answers you get. And then you can choose between two JSON output formats. You can either give the final answer, or you say, this is the queries I would like to search. Right? And then it's doing it again. It's getting again, what is it should never, as it was user input, it should never forget what is the original thing it searches about. So that's why it gets always the original user request, the question answer pairs it gets so far, and then the choice, do you want to output final response? Okay, we can give it now. You can give it also without even any question answer pairs. It's like, what color is the sky? Okay, blue. Yeah, this is common sense. Or you can give me a list of all the search terms I should put into a search engine. So, and then, yeah, language model, pretty self-explanatory. There are many. And then this is just minimal code. Also, yeah, just for you to get a feeling, because sometimes it can feel like, yeah, this is agent, and I just sense there's not everything I understood how this works. But then I was hoping that when you see once, this is just a page of prompt, it's an LLM, and it's this tiny piece of code, then everyone can just implement their agent, even without fancy libraries or tools. So it's going through a for loop, and so that's what we see here. So while true loop, actually. And then it just here getting a response from the language model, and then you have this if-else condition in case it's a final response and it returns final response, otherwise it continues. And then, so probably you know that while true loop is not the best design paradigm among programmers, you should avoid, or you get like rejected from the company if you do. So better don't. It could be that this runs forever and just runs out when your credit card is blocked because you cannot pay anymore for the tokens the language model is consuming. So it will automatically stop, no worries. What we implemented, so we implemented also project, open source project, Node, or deep Node deep research. And in this one, we took care of the budget a bit, that we count the tokens, and then at some point, when one single user request consumes too many tokens, then we just say, okay, now you're forced to give final answer, and then if it's, then it has to generate something. So we keep a bit control on our costs. Yeah, do you see an issue so far with our approach? Anyone? Please tell me.
I think you could easily overreach the costs by not optimizing how many queries you want to run, among other things and parameters.
Okay, probably there are many more problems than I initially thought. Yeah, that's correct. So I think of a different problem here. So, I mean, search results from web. Yeah, you run so many queries, and then you get these massive documents as response, and then you do this in a while loop. So it aggregates. So every time we append something to the list of question-answer pairs. That means the context grows a lot, and we don't want to have this. And if we don't append some question-answer pairs then to the context, then it will just ask the same question twice because it doesn't see it was answered already. So after you start with this initial working but maybe costly and limited thing, you can go for a next step. You can solve the context problem by going that way. So this is, in general, I'm a prompt engineer, and in general, I work like this, that I first create a prompt that solves everything until you hit limitations, and then you split up the prompt into smaller prompts and having very specialized prompts for each task. And this is exactly how we do as we do it here. So when the user request comes in, then the first box is really just deciding the next action. Should I do search or should I give the response? And that's it. It's maybe a difficult enough task already to do. And then, I mean, in case it knows the final answer, okay, that path is easy, then we have another call, another prompt that is formulating the final answer. Okay. But in the other case where we need more information to give the answer. There's a different prompt of query generation. And this query generation, this is actually, you think like it's just asking the model, please generate some queries. I spent so much time, like multiple months, because it's not that easy. The model builds in so much bias from its own knowledge, and it's so hard to prompt it in a way that it's really bias-free and goes by first principle when searching. So, for instance, our company was developing a lot of open source infrastructure code to host AI models, but then in the last 3 years we changed direction and do more in embedding model development. But then when asking something about our company, it always created search terms like GINA AI infrastructure and something like this, because it still has it in its knowledge, and then it's very difficult to tell it first, go by first principle, first find out what is this company doing today when doing competitive analysis, and then what is the product offering and so on, without assuming too much, because all this information can change in real time. That's why this prompt of query generation is actually, it's quite tough, yeah. Okay, then we generate the queries and call all the search indices and retrieve the documents, and then we have another prompt for summarization. So this is solving our issue from before that we partially solving, that we have so large context because we put all the result websites in there. And this summarization prompt is not really like summarizing the whole website, it's like summarizing it specific to the query that was created and what the user wants to. And it can be like a snippet you also have in search engines that is just providing very short string, defining what is relevant to the current search query. And that helps a lot. It's like factor 100 or so faster just because of this. And then you might also realize many of the search results you don't even need because so sometimes it's just not, the information you're looking for is just not in there. And then you totally remove this. And you have a very, very small context. So this is our open source project for this type of search. It's called Node Deep Research. Was initiated and mostly contributed by our founder, Dr. Hönicke. And it is a show. It's also, beside its usefulness and everything, it's also a showcase that it's relatively easy for a lot of companies, for a lot of people to create their own agentic search. Because he created this just within a few days. And yeah, so actually nothing more to say. You can just download it. And yeah, now I would like to go a bit more into use cases. And I would like to propose you a couple of use cases I found. And then I would like to hear from someone what is their data they have at work, and what type of data, and what problems usually come up, and how we could solve them with an agentic search system. So maybe you already have in mind thinking about possible applications for you. So in my career, very often this question came up: what is our main competitor? How can we tackle them? And I feel like generations of employees always solve the same problem, but again and again. But you see, there is some pattern to it, and why not having an agent that solves this partially, at least? So it could find previous analysis. Maybe a company was doing something and putting in Google Drive or some previous analysis, some tables where it can find information from. in this loop iteration, right? It makes a query, this time not to your public search engine, but to your internal document search. So you have your documents index. What products do we offer? Where are our markets? Might be interesting to find competitors. Might be only competitors if they are operating in the same market, competing with you, and so on. So many more questions, but there are certainly some things it cannot do. It cannot send, or it could send an email when you give it the tool use, but you probably don't want to. You can formulate an email, right? We have this typical human in the loop thing also here. Sometimes it helps also to just talk to a colleague in person, and we're not that far with agentic search that everything is optimized. So certain things it can do, others it cannot. Then another very popular use case is so these technical problems that come up from time to time, and you try to find out back then, how did we solve this? It was created so much downtime, and then engineers came in. You have this pressure of solving it in that very moment. And yeah, this is also where agentic search could read through all the logs, all the previous conversations, maybe even archived Slack conversations, and then finding the incident back then. And from there, reading again the logs, and then finding out what happened, and reading the code changes that that were introduced at the very exact time, and so on. So this can actually be quite helpful for this. But human interaction still. Maybe you just call this one colleague who solved this last time, and he's like, or she is like, just blip and solved. So this is also possibility. Or what are the top complaints from our customers? This is also something I got a lot. Customer review, this kind of thing. But you see, I could go infinitely with this, listing a lot of possible use cases. And because it's almost infinite list, I think it's now good to turn more to you and think about your specific use case you have in mind, because then you can talk about something that is of most relevant to you. So is someone willing to share certain repeating challenge, the data analysis challenge that comes up from time to time, or you had a lot in your career, or you noticed other companies have, but not yours? You are? Okay, thank you.
Yeah, I'm working at the French Parliament, and what things were many times we're doing is search for low references about some topics, and so I'm trying to use Agentic search to find the low references to improve our database, and it's quite challenging.
Mm-hmm. Well, that would be interesting to find out what is the main challenge, or what are main challenges for you. What do you think is like most?
Because we don't have just to find the answer to the question, but also the reference of the article of the law that is talking about it, and not just a random answer on the internet.
Okay, so the challenge here is that it's a private database, or?
No, it's public, but open. If you do a search on Google, you could find a response of many websites, for example, a website of a law agency on the internet, and not the official law of the French law, for example.
Okay, it might be not truthful what you find there. That's the problem. That it's just not certified entity search results. That's it. Okay, I see. Yeah. Yeah. I mean, we could blacklist certain websites or whitelist certain websites, so that it's supported by most search engines. I know, like Brave Search, you can find out like what websites to block, what to ignore. I think it's challenging, but then of course you limit a lot the possible search results, and you get the next problem that you only have the truthful and the trustful entries, but then the list of search results is empty because there's none. Yeah.
We have to find websites on the internet that are talking about the topic, and often they don't get the reference, but sometimes they get the reference to the true reference. That's why you have to jump from website to website and find the good reference we need.
Just out of curiosity, how many steps does your agent usually take before providing a final answer?
Right now it's not working very well, I found, but it's some fun 10 steps.
10 steps, yeah. Okay, cool. Thanks a lot for sharing this. Yeah, would someone else like to say something? Yeah, take.
I worked recently in a project using GNAP3 and Neo4j2 because one of the big problems we had was our client was looking for exhaustivity. So
for what? For what? For what?
Exhaustivity.
What is exhaustivity?
Sorry, that's not an English word. Maybe it's not my first language.
Or you can describe.
To find like all of the things related to one other things. Sorry. Exhaustive. Yeah.
Exhaustive search, yeah. No, thank you.
And so, so for example, it was for big database of papers and researchers. And it was like finding all the cumulative citations of one researcher. So it involves finding the 100 paper of one researcher, and then adding everything and so on. And so we used agentic search with Neo4j, with Cypher and complex query written by the LLM, and also using hybrid search to find the entry point in the graph, to find the researcher or the paper that will guide our search. But yeah, it was guided by having exhaustive results and complex queries with 4 or 5 steps. And classic hybrid search with agentic search was not enough, so we had to put the data into a knowledge graph and give access to it.
Okay, interesting. So main challenge was to have completeness, exhaustively, queries provide all lists of embedding models from certain company or something like this, and then it should go out there and find all of them. And if it didn't find all, it basically failed. So it's a very tough, a very difficult task, right?
Yeah, and also sometimes the intermediate steps were not possible to put into the context window, because here I said 100 papers, but if in the search it's more 2000 and something, anything, you cannot really put it into the context window, it's not really relevant. So we had to find ways, and the Cypher or SQL or query languages are really well fit, because you can have several steps that are abstracted by the LLM while writing the query.
So in this where you also use embedding models then for retrieval?
The hybrid search was just to find the entry point in the graph, the exact ID from which we will launch the graph query, because to do a search in the graph you have to have the exact node you want to search from. So it was usually 1 or 2 hybrid search to find the correct IDs, and then several graph queries to find the relevant information.
Okay, cool. Yeah, thanks. So, we have seen 2 people who already implemented agentic search, and I think most of us didn't. So based on all the things you found out, okay, it can search on internal data, It can then make multiple searches and give the final response. Is there a use case you would see within your company, even knowing you would be far from implementing such thing also? Do you have some? And please don't leave this question unanswered, because then I would just cry.